Okay, here are the things that are given to us in the problem. VI is 55 meters per second. We don't know the theta. We know the dx to be 175. And we know our dy to be 22. I'm going to make two formulas real quick. First, my x formula. And that's dx equals vxt plus 1 half at squared. My next one's going to be dy equals vyit plus 1 half ayt squared. And we should know that our ay equals negative 9.81 meters per second. I'm going to leave that off just for speed. This is 0. All right, so that simplifies this quite a bit. That makes dx equal to vxt, and that makes dy, well, nothing really cancels out. I'm going to start plugging in for dy. 22 meters equals vyit minus 4.905, leaving units off today, t squared. All right. Now, my next phase of plugging in is I'm going to talk about my x's and my y's, my velocities. Vx equals vi cos theta, and vyi equals vi sine theta. So we got that. Let's move on. Now, let's plug it in. You get dx, which is 175 meters, equals vi cos theta t. I'm going to, sure, vi cos theta t. And then this over here, well, this is going to become very expansive and very complicated very quick. I'm going to write down real quick my quadratic equation, because that's what this is basically going to become. This is going to become, this is your C, this is your B, and this is your A. Now remember, this is going to be negative, but whatevs. So, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now what I'm going to do is I'm going to plug in real quick. I'm going to solve this for t, and you'll see why in a second. So this is going to be dx over vi cos theta equals t. Okay? In this one, when I do the quadratic equation, remember our x is going to be actually the t squared. So you get t equals negative b, which is, I'm just going to leave it as vyi. You guys know what it is. It's vi sine theta plus or minus the square root of b. I didn't want to do that. Control C, Control Z. Plus or minus the square root of what is my b? I'm going to call it vyi squared minus 4 ay. I'll put that there. Oh, that's not right either. It's actually negative 4.905, leaving my units off. Multiplied last but not least, and it's barely going to fit there, but multiplied last by our c, which is 22 meters. All of this is over 9.81 meters per second squared. Now you might say, well, shouldn't it be 2 times that? No, it's actually 2 times this. So you get this value, and you see how these two are equal? So you can set them equal to each other. And I'm going to make an equation that goes like this. dx equals, parenthesis, negative vyi plus or minus the square root vyi squared minus 4 negative 4.905 22 all of this over 9.81, and all this multiplied by, and it's going to be very hard to fit in here, it's actually multiplied by vi cos theta. All this in the parentheses multiplied by that. Okay, so you may be saying, well, what have I done? Well, I'll show you guys. I've made a mapping function. So here I go. I'm going to go to Excel. And here's my finished product. But I'll show you how I got that. And let me just steal something real quick. I'm going to steal this, copy. So, escape. That did not work out. So basically what this sheet says is here's the angle. Ugh, this is getting on my nerves. This is where Excel drives me crazy. So here we go. We're back here. We've got our sheet made, and this did not work at all. Come on. Copy. No, I don't want that. Copy. There we go. Finally got it. Okay. So that's going to give us a weird thing right now. But you may be wondering what I'm doing right now, but I'm inserting in my mapping function ever so slightly. And you can look at this later. And they should all say that they're impossible. So I'm going to start off with 90 degrees, okay? And then I have my Vx. And remember, Vx is going to be equal to 55 cosine, and I got to put the star thing, cosine. Now I have to convert it from radians. This value, close parenthesis, enter. And you'll see that this is actually what that value is. And that's pretty interesting. It should actually be 0. It's really close to 0. And that our Vy equals 55. People need to stop calling me. Sine. Ugh, radians. Very annoying, I know. Multiply by this. Close it. Enter. There we go. And that should make sense too, because the y component of this should be 55 and this should be 0. And g, we all know that is negative 9.81. Enter. And then our dy, what was our dy? It was 22. And this may be strange over here, but we're starting to get a mapping function. Just turning my phone off. People need to stop it. All right. So now what I'm going to do is I'm just going to drag this down as far as I'd like. And I'm not going to go, well, let's just go all the way. I'm going up. I don't want to go up. Control C. 89. Enter. And watch as I drag this down. You'll see that I have two values. These right two columns. You may say these are strange and they are kind of nonsensical. And they in fact came out a little different. Did I? Oh, okay, I started at 0 over here. Okay, so what we'll see is this, is that this is actually our dx. These two values right here are our dx. Now remember, the quadratic equation, when you look at it right here, it has a plus or minus. So this formula, when I show you, and you can freeze and look at my formula, when I do this formula, notice this one is positive, and, well actually, sorry, this is positive, and this is negative. And using these two, because you have to have plus and minus, and I can't do them both at once, I have done them separately, and I've made my ranges. Now notice, there's some important things, like right here. Why is this important? Well, I told you that these are my dx's. And do you see that right here, around 72 degrees, that is where we get very close to 175. This is one of our angles. Pretty close to 72 will get you a range of 175, exactly like our problem wants us to. If we keep going as well, you'll notice that right here, like right here, right around here, we also get another range, and that's about 23. Oh no, the angle's about 25. So there are our two locations. There are our two ones. I think that one might be a little bit off. That's kind of strange compared to what I've seen in some people's calculations. But those two, that's how I found these values. I set up the equation like I did over here. I made this, and then I brought this over to Excel, and I did the entire spectrum of angles, and I found where my range got close to the value. Notice the plus range never actually gets close. The minus range, though, hits it twice. And if you also want to look at it, here's this graph. I made this nice graph also the other day when I finished this up. And you'll see that here's our graph of our plus range. Well, I think I have this mislabeled because I think this is supposed to be my minus range. But as you can see that it hits it here and here around 175, and these are our two angles that give us those values. And that's how I found it. Okay, guys.